So in this week's workshop series, we focused on using Python using Google Colab. It's a very nice option. It doesn't require you to install Python at all on your machine. But in some cases, when you're starting to do Python programming at a more serious level, you're going to want to install Python on your individual computer, be it your laptop or your desktop computer. And I wanted to go through some of how you do that and some of the differences between using Python on Google Colab and using it on your individual computer. So the process to install Python is relatively simple. I won't go into it too much, but we'll provide some resources on how to do that installation. But essentially, you would just download the package from the python.org website. And there is going to be, depending on when you're watching this video, when you go to the download section of the website, there is going to be a particular latest version of Python. And when you go to this particular page, you're going to be shown the version for your particular OS. And so I'm using Windows, but if you are perhaps using a Macintosh, you will see a little bit of a different screen here. The current version of Python, the most latest version of Python, depending on when when I'm making this video, is 3.11. But there are somewhat regular updates to Python, and if you happen to, for any reason, need an older version of Python, they are often available on this page as well. As you can scroll here, it has all the stable versions of previous iterations of Python. But in most cases, you will be fine with the most latest version of Python. In most cases, the libraries that you might use in Python are backward compatible, so it's always helpful to have the latest version of Python. One thing you might notice, I guess there's been two major iterations of Python over the last decade or so, Python 3 and Python 2. At this point, you should probably always use Python 3. You may see older textbooks or documentation that have references to Python 2. Some of the syntax between Python 2 and Python 3 is different, and so oftentimes code written in Python 2 won't work in Python 3, but it has been quite some time since the advent of Python 3, and so just ensure if you're doing any other learning using books or other things that the version of Python that book is geared towards is Python 3. And it should be for the most part. But just know that there are some older versions of Python. And then within those versions of 2 and 3, there are several other iterations as well. So just go with the latest Python version and you should be fine for the most case. But essentially what you will do is you'll download either the installer for Windows or the package for Mac OS, and then you will follow the steps, the prompts that are provided for you when you do that process. And it's relatively easy. Just visit some of the resources we shared for more details on that. The one thing I also wanted to note is that, I'm right now on the page for the default version of Python, but there has also been some, for lack of a better word, Python distributions that have been geared towards certain, functionalities and certain things. And so since this course that we're taking is related to kind of AI and computational work, one common Python distribution that I wanted to highlight is Anaconda. And so the installation process is very similar. So if you're going to do a lot of AI-based work or even kind of statistical numerical analysis-based work, you may want to, instead of using the default installation of Python, you might want to choose to install something like the Anaconda distribution of it. And the essential main difference and one of the nice features of a distribution like Anaconda is that it has a lot of the Python libraries that are required for, in this case, artificial intelligence-based work already installed. And so one of the challenges with Python, and we'll see how to do this, is that there are many, many different libraries that do many different things. There are certain, functionalities built into Python, but to get some of that extra functionalities, you have to install libraries, external libraries that have been developed by different individuals. And it's not a hard process, and we'll go through an example of how you do it. But one of the nice things with a distribution like Anaconda is that it has a lot of those different libraries installed already. So essentially, once you've installed Anaconda, you won't necessarily have to reinstall or try to install common functionality that you might use when you do AI work. So for example, there's the pandas library that is done to do statistical analysis and number manipulation. Pandas is quite popular. Matplotlib is another one you can see here that is done for used for plotting numerical sets. So there's a lot of, and they're all here. I'm not going to go through all of them, but there's a lot of different AI and numerical analysis based libraries that are built in to the Anaconda distribution. One of the drawbacks with that is that it is a quite large file size. So it's about 600 megabytes, which is significantly larger than the kind of default Python. And because of some of the compatibility requirements for some of the libraries included with Anaconda, it also runs a slightly older version of Python as well, so Python 3.9. So I won't go into it too much more, but know that there are a couple of different ways that you can install Python. You can use the default version, which is what I typically do. Or if you really want to focus on doing AI work and numerical distribution, you can use a version like Anaconda. And you don't necessarily lose anything by installing the default version of Python, but you may have to manually install more libraries where, again, Anaconda has some of that included for you. So once you've installed Python, either the default version or a distribution like Anaconda, you're obviously going to want to do something with it. And the process of how you do it is obviously different than if you were using something like Google Colab. And so typically you will run Python using, if you're, for example, on Windows, using the command prompt, or if you're on a Macintosh or a Linux-based computer, you will use the terminal. So we'll open up the command prompt. Again, I'm on Windows. So I've created a special directory for our examples here. So in command prompt, I will move to that directory. So I'll go there, and then I've called it Python.ai. And so essentially I have a directory where I'm going to put all my Python related code. But if you've successfully installed Python, you should be able to run what is called the Python interpreter. The Python is an interpreted language, so you will run all of your text-based code through an interpreter. And typically, the way that you will run Python code is by putting all of your code in a text file and then running that code with the Python interpreter. But you can also run code in the interpreter itself. And I don't do that very often, but it's a nice way just to ensure that the Python installation is working properly. So if everything is set up properly with your Python install, and if you were just to type Python, essentially what happens is the Python interpreter begins. And so you will typically see the version of Python that you are running. In my case, it is 3.11, which is the latest version. And then you will see these little, I guess they're chevrons or greater than symbols. And essentially what you're doing here is you can essentially run Python code one line at a time. So for example, we could go something like number equals, and then we'll go 1 plus 10, and then we will press the enter key. So that is one line of code. And then we can go, let's say, print number, and press enter again. And you can see here that we have the results. And so I don't use it very often, but it's an interesting way that you can kind of run commands one at a time. But I think Python becomes far more useful if you're using the Python interpreter with separate files. And so the typical way that you want to work with your Python files is by using a text editor. So this, I have open here now Atom, and Atom is just one example of a text editor. And there are many. They all seem to have similar functionalities. And they have some advantages over essentially using something as basic as Notepad to work on your text code. And we'll go through some of that with an example. And so again, how you do these steps will depend on your actual text editor, but let's just use Atom to show some of the I guess, advantages of using a text editor over something like Notepad to work on your Python files. And so one thing to note is that every Python file generally will have the extension of .py. And let's just start a new one. One of the nice things about Atom in particular is that you can open up folders which essentially act as projects for your Python code. And so you can go, I've already done that in this case, but if you wanted to have all of your different Python files and libraries and such in a directory, you would put them in a directory. And then if you wanted to open that directory within Atom, you would just go to Open Folder, then select the directory, which we've already done. And then you would have all of the files listed here on the left-hand side of Atom. And so essentially in this case, we only have one file, but let's create a new one. And so you can create a new file by just right-clicking here and then going New File. And then we'll give it a name. So let's call this test.py. Again, Python files will have a py extension. And so now it is open up in Atom. And so it's an empty file, obviously. One thing you might note, it might be a little hard to see, but there's a little gray line here. A good programming practice is essentially trying not to make your lines too long, so they're more easily viewable on a screen. And this little gray line gives you an indication of when you might be having your lines too long and might have to span them over a couple of different pages, a couple of different lines, sorry. So let's write a very simple Python program just to get a sense of what you can do with a text editor like Atom. So let's just do some addition. So let's define two numbers. So let's say number 1 equals 10, number 2 equals 15. And you can already see some of the advantages here. We have line numbers, which is nice because essentially if you're going to be sharing your code with other individuals, it can be helpful to refer to the line number. So you'll say, hey Bob, can you take a look at the code on line 4? And most often Notepad-based editors may not have those line numbers, so it's particularly helpful to have them. Another nice feature that you can see here is the color coding of text as well, which makes things a little bit easier when you have big pieces of text. This color formatting will allow you to more clearly see things like variables and function names, etc. So we've defined two numbers. Let's do a little function as well. Maybe we'll use this function to add these numbers together. So we'll go def, and then we will call that add two numbers. And then we will pass it into variables. So number 1, number 2, and then we'll do a little colon. And again, another nice feature is that as we saw through our workshop series, Python does, it organizes its code blocks using tabs. And with this text editor, when you automatically press enter, when I was finished this line here, line number 4, it automatically does the tabbing for you. So that's another nice feature. So we will just do something simple and say result equals number 1 plus number 2, and then we will return that, and we'll return the result so that we can have the number be displayed by a command outside of this function. And then we will just call that function. So we'll add two numbers. And then we'll do that within a print so that we can see the result. So print, and you can put a function within a print. So then add two numbers. And you can also see something I just saw there, in that you can do autocomplete as well. So when you may have seen that as I was typing, it recognizes that I have a function that starts with add, and at this point I can just press tab and it automatically completes it for me, which is kind of nice. It's a quick way to speed up the process of doing code. And that's one of the big benefits of using a text editor. It simplifies and speeds up the process of creating your code, particularly when you're working on larger projects with a lot of different functions and a lot of different files. It then becomes very handy to have this project window and some of those the autocomplete functionality and some of these text coloring highlights as well. So we're going to print. We need to call our function and send our two numbers in. So number 1 and number 2, and we will save. And now essentially we have a complete Python program. We've defined two variables, two integers, 10 and 15. We've created a function called add2numbers, which we will pass two numbers into. We will then add those numbers. And because we want to use this value outside of this function, we will return it, and we will return that other variable that we set here, result. And then we have to call that function if we want to actually do something with it. So we will put that function within a print variable because we want to print this actual result. And then we will go add two numbers. So we'll call our function, and then we will pass it these two numbers before. And in this case, the numbers are the variables that I've passed into the function. The names are the same, but we could, for example, change this to, let's say, number first and number two, and then change this to number first and number two. And it would operate the same way. They don't have to be the same, but in some cases it's just simple for a program like this to have the variable names be the same, but it doesn't necessarily matter. What you're passing in here can be any variable name. So essentially we have this sample program now. And so if we want to actually see the results, what do we do next? And so to actually run this program, we have to again go back to the command prompt or the terminal in the case of a Macintosh or Linux computer, and run it through the Python interpreter. And so we'll go back to our command prompt window. And again, we're within our python.ai directory, which we are working in within Atom here. And we will just type Python and the name of our file, so test.py in this case, and press enter. And so there was a syntax error. So this is the one thing that's nice about the Python programming language as well, is that its error messages are quite good. And so you might notice here is that I didn't include a closing bracket here. So we just need to add that and save the file again, which is just Control S using Atom, and we'll run it again. And in this case, it should probably run properly. There we go. And so we have essentially added our two numbers together, 10 and 15, which adds up to 25, and then we've print them. So that's the general process of how you run Python code. So you put all of your commands in a text file with the extension of py, and then you will go to your command prompt or your terminal, and you will type Python, and then the name of the file that you want to run, or the Python script that you want to run, and then it will output your results to the screen. So in this case, it was 25. So as we talked about in our workshop series, one of the biggest advantages of the Python programming environment is the fact that there are many libraries that have been created by different individuals to do a lot of different tasks. And that's handy because we don't necessarily have to create a lot of that programming from scratch. Python is one of the most significantly used programming languages, particularly by intermediate programmers like ourselves. And because of that, big base of people using the programming language, pretty much almost any function that you can think of related to our task that you could do with a programming language, somebody has created a Python library to make that relatively simple, which is nice because you don't have to create it from scratch, and you don't necessarily need to know those advanced programming functions to do that type of work, to take advantage of something like Python to automate either your research or your work. And when we went through our earlier examples in our earlier workshop series of doing sentiment analysis, one of those libraries that was particularly helpful was the Vader sentiment library. And I wanted to kind of quickly go through how you load one of these external libraries onto your computer so that you can take advantage of them using Python. And so I wanted to open up a script quickly before we do that to show you a simple example, I guess, and we'll go through this in more detail, but essentially I'm trying to use this Vader sentiment library. And to access that Vader sentiment library, I've done an import of, and there's a couple of different ways you can import Python libraries, but in this case, this is the kind of format that you're going to use. So you're going to use from Vader sentiment, and then you're going to import the sentiment analyzer, which is the function that I want to do. And then essentially, and I'll go through this in more detail shortly, but essentially I want to do sentiment analysis on all of these different sentences. And this is an example from the Vader library page. And then I've created a function that actually goes through this Python list and does the sentiment for each one. But one of the challenges is that I have not installed the Vader sentiment library yet on my machine. So if I was to run this example, again, back to the command prompt and run example.py, I will get an error that says no module named Vader sentiment has been installed because I have not installed the library on my machine. This is not one of the default libraries that is included with Python. And so if you wanted to do that, so actually do that installation, you will typically use a process called pip. And you can, the command varies from library to library, but the nice thing is that you can, this is an example of a page that describes a particular Python library, and usually at the top of that page it will give you details on how to install that library. So this is the py, so pypi.org, which is essentially a library of Python libraries, and there'll be a page like this for every library that you are able to install. Oftentimes it has somewhat limited details on it, and if you want more details on it, you will typically go to the home page, which is usually listed here, which in most cases is a entry on GitHub. So again, you can look through the GitHub page to get a bit more detail on how you run the library, how you set up the code for the library as well, some of the different ways you can use it. And the challenging thing with GitHub is that these pages will often be formatted in different ways, but typically they will have an option for installation as well. So again, you will either see a page like this for a Python library, or you will probably come across a GitHub page. And hopefully if the GitHub page is set up well, there will be a little bit of a more detail on how to install it and how to actually use the library itself. But we can see in both of these examples that the code to essentially install Vader is pip, then install, and then Vader sentiment. So we will copy this, and you can do that by just clicking on these little, I guess they're pages. And then we'll go back to our command prompt, and then we will type it in, or we'll just copy and paste it, and then we will press enter. And essentially what will happen is that it will install the Vader sentiment library. And that process is essentially how you can install any library. So for example, there'll always be some type of command that typically is pip install and then the name of the library, and then you would run that within your command prompt and your terminal, and then that library would be available to use within your Python code. So if I was to run that Python code again, now that I've installed the library, so again Python and then example.py, we can now see that we get a variety of the Python, of the Vader sentiment scores for all of our different sentiments here, for all of our different sentences here. So example, you can see that for each one of these, we have a different score for both the amount of negative sentiment, the neutral sentiment, the positive sentiment, and then that compound score. So again, this is the same process that we could have done with something with Butter, using the Python, actual programming on our local machine instead. So let's look at the code a little bit to understand it a little bit better. And we will switch back to Atom. And this is a relatively simple program, but our first step when we're using an external library is importing that library within our Python program. And this the code that, maybe I'll make it a little larger, the code that you use to import the library will change from library to library. Sometimes you don't, all you have to do is put an import statement like this here. But in this case, you will always really refer to the GitHub page or the Py library page to get a sense of what is the best way to import in your library. And in this case, if we go back to our page, there was a couple of different options, but we can see from this example, from this code sample that's included on the GitHub page, that the proper way to import our library is as this set of text here. And that will vary a little bit depending on the library. So once we've had that, essentially what we have then done is created a Python list of different sentences that we want to do sentiment analysis on. And so each one of these items, so a list is always contained within square brackets. And then we have essentially a list of strings in this case. and we've called it sentence list, and we have, I'm not sure how many there are, 10 or 12 different sentences that we want to get a sense of whether it is positive or negative. And so we just create the list. And then we've essentially created a function here, and all functions start with df, then they're given a name, and then you would, in this case, pass a variable to it, and that variable, again, is our list of strings of sentences that we want to analyze. So with the Vader sentiment analysis tool, we have to first initialize it, so we call this analyzer, we call the sentiment analyzer function, and we set it to analyzer so that we can essentially use it to do our scores. And then we will do a for loop to go through each one of these sentences. And so we have for sentence, so that's the individual sentence, in sentences, which is the list. And so again, we pass sentence list to our function. So we're essentially going through each one of the sentences, the strings within our list individually, and then we will do our sentiment analysis on them. And so we will, and this again, this formatting of how you do that, do things within a library will change. But in this case, with Vader, you essentially take your analyzer code from before, and then there is a function called polarity score, polarity underscore scores, and then you will pass your sentence to it. And then essentially we want to print out what it returns. And that's what we got here, where we essentially had the scores for each one of our individual items. We can make this a little bit better by maybe also printing out our sentence as well, so we know what the sentence is. So we'll just go print, and then within brackets we'll put sentence, and we will save it again. So we've made our change. If we run this program again, we can now not only, I'll make this command prompt a little bit larger. So now we also have the sentences and the related scores. And so you can get a sense here from the Vader scores that all of these first set of sentences are quite positive. And as we knew from our workshop series, Vader can measure the amount of positivity as well. That's why you see these getting a little bit larger. And then, for example, if you see this sentence here where Vader is not smart, handsome, nor funny, you can see it has a negative score as well. And so that's the very basics of how you can use Python on your machine rather than using it via something like Google Colab. Again, if you start doing more serious work on using Python with larger files and working on multiple files, it can be more helpful or a little bit more easier to do that type of work on your individual machines, particularly as file sizes grow and as you're using interrelated files with one another. It can be helpful to do that type of work on your own individual computer rather than Google Colab. Google Colab is a great tool for learning Python. It's a great tool to take advantage of some of the GPU resources which are available for free through it, which is oftentimes a nice requirement of a requirement of doing AI work. But one of the challenges is then, when you want complete control over the environment that you're doing development in. So for example, if you want particular versions of Python or particular versions of libraries installed, you have more control over what your Python programming environment might be when you're working on your individual computer than you would if you are trying to use Google Colab. I've come across some examples of when I've tried to, even though Google Colab also allows you to install libraries, there's been some incompatibilities with certain libraries and Google Colab, and you can oftentimes overcome those incompatibilities on your local computer because you have more control over what versions of Python you might be using or what versions of the library that might be installed. And that's more challenging to do within a Google Colab based environment. And so they both have their purposes, but for me as a researcher and a worker, I now more often work on my individual computer. And so it's nice to have the ability to work within both environments, particularly if you're doing larger projects that require more libraries and might have more interdependencies. And again, for more details on how to install Python and some of the different resources and how you can learn it and some of the different distributions that you can find related to it and some interesting libraries as well, please visit our website where we have a list of those resources.